Hello and assalamu alaikum. How are you, students? I hope you all will be fine and enjoying your life. I'm here today to solve a question from Intermediate Mathematics new book in exercise 2.3, class 12. So the question is, find the nth term and limit of the following sequences. So there are two sequences. We are going to find the limit first of this sequence, and then we will go to find out the limit of this sequence. So um, this is a question: one upon 2, or 1 divided by 4, and then 1 over 8, and so on. First of all, we have to recognize that which kind of sequence is this. For that, we have the three kinds of sequences. One is arithmetic, geometric, and harmonic sequence. As for arithmetic, we just find the difference between the two numbers. Either, for example, it's 1 over 8, then minus or subtract 1 over 4. If the difference between all these two numbers is same, then we can say that it's a arithmetic sequence. But here I guess this is not arithmetic sequence, because the difference between the two consecutive numbers is not same as 1 over 8, and then minus 1 over 4 is not same as 1 over 4 minus 1 over 2, and it is not same as 1 over 2 minus 1. Hence these the this cannot be arithmetic sequence. So we will try for a geometric sequence, which says you have to find the common ratio between the two consecutive numbers. Here, if we have 1 upon 4, and we divide 1 upon 4 with 1 over 2, which is like r is equal to b over a. This r stands for ratio, and this b stands for second value divided by first value. This means this is second value and this is first value. So we divide 1 upon 4 with 1 over 2, we will get 1 by 2. And if you divide 1 over 8 by 1 over 4, again you will get 1 upon 2. So hence we have the common ratio, which is 1 over 2. And if the ratio is common between these two terms and these two terms and these two terms, we can say that it's a geometric sequence. So now, when we know this is a geometric sequence, we can find out the nth term for this sequence. So the nth term for this sequence will be, we will use the general formula for finding the geometric sequence and its nth term, or we can say that the general term. So these are both same, nth term or general term. Hence, so this is not in need, or is less than 1 is not in need. So the general formula for finding the nth term or general term for this sequence is an is equal to a1 r power n minus 1, or in some books it's written a1, in some books it's not, it's just only a r power n minus 1. So this is the formula for finding the general term of this sequence, this geometric sequence. Now here an stands for general term, or and then we have this a1, which is equal to 1, the first value. A1 is the first value of the sequence, which is 1, and r is the common ratio which we have found from this sequence, which is 1 by 2. We will write 1 by 2, and then n, because we need nth term or general term, we will not put any value in place of n. We just write n as it is. So n minus 1. Hence this power n minus 1 is on 1, and this is also on 2. When you multiply this with 1, you will get the same answer. So any power on 1 will not affect the value of 1, which we will get again that 1. And this power n minus 1 we have written here as it is. Now, to find the limit of this sequence, we will be like applying the limit on both sides, or taking limit on both sides. Limit n tends to infinity of an, and the limit of this term n tends to infinity of this one. So now for that, now there is nothing to be evaluated further. So hence we will apply the limit n tends to infinity of an, and then we will put that limit in place of the n and then infinity. We will replace n with infinity, because we are applying the limit. So 1 over 2 power infinity times 2 power minus 1. So hence you see that we can also write this number as 2 power n and times 2 power minus 1, because when bases are same, powers will be added. So the bases of these two are same. Further, when you combine, or when you add the powers, you can get the same result here. 1 over 2 power infinity times 2 power minus 1, and we know that 1 over infinity is 0. So any number having power infinity, which is also 0. Sorry, not 0 but infinity. So 2 power infinity is infinity again. 1 over infinity becomes 0. Hence 1 over 2 power infinity times 1 over 2 power minus 1, this whole value is equal to 0, times 1 over 2 power minus 1 is will become 0. So the limit of this sequence is 0. Hence it makes sense. How it makes sense? Because if I have like one apple, you know if I have one apple and I give that apple to a one people, he or she have the whole apple. And if I divide that apple within two peoples, they will get half. And if I divide that one apple in four people, they will get a quarter or one fourth, and then one eighth, and so on and so forth. If I divide that one apple into too many peoples, like infinite peoples, or somewhere like 2 million peoples, how much each of one get? So they will probably get nothing. Maybe it will be like they are getting something, we call it 0. So this makes sense. The limit of this is going to be 0. All right, I hope you understood this point, and wish you good luck. We will solve this problem, inshallah aziz, on in any next video. Till then, goodbye, see you, and Allah nigeba.